Okay, we're given this system of linear inequalities and asked to graph the solution set. So we have to graph each linear inequality separately and look where they all overlap. So starting with the first one, we first graph the line 2x minus 3y equals, minus 3 is equal to y. So we need a little x, 2 points on the line to graph it. If x is 0, then y is equal to negative 3. And let's see, if x equals 2, then 2 times 2 is 4 minus 3, y will equal 1. So there's 2 points on the graph of that line. So we can graph the first line. And so let's see, so we have 0, negative 3. Well, 0, negative 3 is the y-intercept. So there's the first point on that line, 0, negative 3. Then go over 2, and I have to go up 1. There's the second point on that line. This is going to be a solid line because it's or equal to. So here's our first line's graph. We have to decide which side of that line we need to shade. So for part 2, we can ask, is the origin shaded? We answer that by taking the inequality, 2x minus 3 bigger than or equal to y, and seeing if it's true when we plug in x equals 0 and y equals 0. So negative 3 is bigger than or equal to 0 is false. So the answer is no. So it's the opposite side that we shade for this line. So it's everything over here to the right and the lower side of this line. Okay, so that's the first one. 3 to go. So for the second one, we have to first graph the line x plus 2 equals 2 times y. So finding an xy pair on this line, if y is 0, then x plus 2 adds up to 0, so x must be negative 2. So that's a x-intercept here at negative 2. Now, on the other hand, if x is 0, then 2 is equal to 2 times y. Well, 2 times 1 is equal to 2. So there's 2 points on this line, so we can graph it. So the x-intercept is at negative 2, and the y-intercept is at 1. So this line, which is going to be a dashed line now because it's a strict inequality, is the line through these 2 points. And now we have to decide which side of that line to shade. So we ask, is the origin shaded? By plugging in the original inequality, x plus 2 is less than 2y. When x is 0 and y is 0, this becomes 2 is less than 0, which is false. So the answer to our question is no. So the origin is not on the shady side of that line, so it must be the top side of that line that's shaded. So everything up here is shaded for this one. Remember, the region we're looking for is where these regions all overlap. So we've got a triangular, this wedge up at the top. Because this one keeps going, so we keep getting more and more up there. But we have 2 more inequalities to go. So for the third inequality, we have the same 2 questions to ask. First of all, we graph the boundary line, the line 2y equals x plus 3. So we need 2 points on that line to graph it. And if y is equal to 0, then negative 3 plus 3 is equal to 0, so y would equal negative 3. And let's see, what other point can we have? If if x equals 3, 3 plus 3 is 6, 2 times 3 is 6. So 2 times 3 is 6 equals 3 plus 3. So those are 2 points on this for this third inequality. Let's graph the line. Let's graph that line then. It's going to be a solid line because this is an or equal to inequality. So negative 3 comma 0 is over here. That's the x-intercept at negative 3 on the x-axis. And then 3 comma 3. So if I go over 3, I have to go up 3. So there's a second point on this line. And this is a dashed line, so it looks like this. Notice that this line looks like it's parallel to the other line, the second integral. So these last two appear to be parallel. And notice that this is a 2y on one side and an x on the other, so it has a slope of 1/2. If you divide by 2, it'll be 1/2 x. This has a slope of a half. Divide by 2 here, you have a half x here. So they both have the same slope. They not only appear to be parallel, these two lines, they are parallel because they have the same slope. Okay, in any case, now we need to decide for this the dotted line we just drew in, which side of it to shade. So we ask, is the origin shaded? And we plug it into the original inequality, 2y less than or equal to x plus 3. Plug in x equals 0 and y equals 0. It becomes 0 is less than or equal to 3, which is true. So the answer to this is yes. This time the origin is on the shady side of our line. So it's everything below. See, that one's not going to work very well. Let me find another color here. So it's everything below this last shady line. We have one more inequality still to go. So notice that so far it's the region between these two dotted lines, these two parallel dotted lines. So the region between these two dotted lines coming down to here, where it stops at this line. But we have one more inequality to go. And I'm going to start over here for that one. Well, it's simply y is less than 5, so this will be a relatively easy one. So we graph y equals 5. That's the horizontal line through 5. So that's 3, 4, 5. And this is going to be a dashed line. So we have a horizontal line through 5 here. We decide which side of that line to shade, but it's y is smaller than 5. That's the down side of the line because y is smaller than means it's below. So we graph below that last dashed line, and I'm going to just draw in the regions that are below that line and also in the intersection of all these other lines. So it's between these two lines from here, but now we have a further restriction. It can't go higher than this point. So it's everything below that last inequality that includes the previously observed solution points. It goes up to there and stops. So we have this little trapezoid region in here. That is our solution set. It stops right there, and it goes this little region up to here where it has a little point on the end. That's our solution region.